Hello everyone, good afternoon. Welcome to the class ECE341, the probability and stochastic process. Today we will keep working on the estimation of parameters, but this time we will give an interval estimation. It's ECE341. This is for the 12th week Wednesday's class. Alright. So here's the estimation, interval estimation. Interval estimation. Okay, so what is the interval estimation? Of course, we should know what is the problem. We have random variable x has a distribution with an unknown parameter C. Yeah, we don't know that's C. And we have this x has samples x1, x2, x3, and so on. Right? You have a sequence. Then try to find an interval A, B, so that the probability of set is a value between A and B. Suppose we want this probability is larger than some beta. Beta is a given level. We call this a confidence level. Let me see. They have several names. I put it here. And we have this part. We have interval. The beta is called the significant level, the confidence level, or confidence coefficient, or just the confidence. Alright, several names. That's it. It's a given number. Of course, it's a positive one, right? Positive one, and also smaller than 1. It's a probability, right? It's a given number, which is called the confidence. Several. I just use one. Okay, confidence level. Yeah, this is confidence level. Okay, this is a problem. So the problem, what do we know? We know these samples. Suppose x has these samples. This is one thing we know. Second thing we know is we know the distribution, part of it, not all of it. We have like this is a suppose like it's a Gaussian distribution, but you do not know mu. You know something about the distribution, but you have some parameter. It's unknown, right? So this is the second thing. So the x to xn, these values, totally you have the value. The distribution, you have some of it. You have a parameter. It is unknown. You know others. You know other things about the distribution, but do not know this set. So this is what do you know, and then what do you want to find? You will try to find the interval, and you want to set is a value between A and B. Of course, this is in the sense of probability. So we say we want to find the interval so that the probability of these set between A and B has a large probability. The probability were larger than that beta. Beta might be like 90%, 95%, or 99%. Right? It's a number close to 1. Beta close to 1. Close to 1. Alright. And you can also think, or you can write it this way: A smaller than theta smaller than B larger than 1 minus alpha. And alpha is also called the confidence level. The same name, alpha beta with the same name, but beta is a large number, alpha is a small number. Alright. Yeah. And this formula we can also write as P theta smaller than A or theta larger than beta. That means theta do not belong to A and B. This one will be this is larger, this will be smaller than alpha, or this. Okay, or this. Alpha is also called the confidence level. Confidence level. Okay. Alright. So the problem is just like this. You have a parameter. You want to find the interval, and you have a big probability that theta will be between these A and B. Okay. Then how to do it? How to do it? We need to use the central limit there. Okay. How to do it? We need a central limit there. Central zero. Let Zn equal to this one. Summation. I can't remember the formula. It's a here. I put it here. This one. The central limit 0. Central limit 0. Okay. Yeah, we have Zn, which is a summation of all of these xi, because I run from 1 to some n, minus n times ex over square root of n times variance of x. Let Zn is like this. Then Zn is also random variable, and it will obey the normal distribution with zero mean and unit variance. Now we have this. Okay, so for this one, we can find an interval with a given probability. Right? We know the f z. I just write z. Okay, it will be a graph look like this, right? And then we can find, like this is a c, this is negative c. We want this interval, the probability larger than beta. Now, beta is a given level, right? We have a confidence level. We want the probability inside this part is larger than beta. In other words, the outside will be with probability smaller than that alpha, right? The half of alpha. You need to separate alpha in two sides. Right? Okay, so by this way, if beta is given, C can be determined. So that Zn absolute value smaller than C, the probability of these will be number larger than beta. Okay, actually almost done. Well, we have an interval. We have this is kind of interval, right? Interval. In this interval, the probability is larger than beta. Okay, we already done, but not totally done, because this one we need to rewrite this part rewrite it in the form A smaller than that theta and smaller than B. We need to rewrite these in this way. Then A, B is the interval, which are the confidence interval. It's a confidence interval. Oh, I think I missed something. Yeah, sorry. This is D. The last is the confidence interval. Yeah. Then this one is the confidence interval of set with the confidence level beta. Alright, then let's do an example. We can see. Okay, the example we can see. Here I have a homework problem. Now I change some values of this homework problem as our example here. Alright. Example. We have a random variable x and has, okay, I still use 100 samples. Yeah, maybe you can have like 1,000 samples or 500 samples. That depends, right? Here I just suppose we get 100 samples, x1, x2 until x100, and we have samples. And we know m 100 of x. This means m, capital M, is a mean of x with 100 samples, right? So that actually this is just you add all this together, divide by 10. Now we suppose we have this one is 4.6, and we want to estimate the parameter. Estimate the parameter with the confidence level beta is 95%. Okay, then we have two cases. For A, x obey the Poisson R distribution. We want to estimate, we want an interval, we want to find an interval estimation of R, of this R, with 95 as the confidence level. Okay. This is the problem. I make some change. Like I put this is a 90%, and this is 14.6. Okay. Suppose I work like this. Some part different, not exactly same as the homework problems. That is homework problems. You need to work on it after the class. All right. Okay. Then how to do it? This is just, you follow the step. The first one, let Zn equal to summation of xi minus n ex over square root of n variance of x. Then Zn will obey the normal distribution with zero mean and unit variance, the standard normal distribution. Okay. Okay. Now we need to determine what are these numbers, right? What are these numbers? Now x obey a Poisson of R, so ex will be what? And the variance of x will be what? Anyone remember that? Actually, I can't remember. But we have the table here. All right, you should know where can you find these values. Okay. Okay, this is textbook in the appendix A in the back of the textbook. Then you can see we have different kind of random variables. We want the Poisson one, which is Poisson. This is the Oscar. Okay, it's here, Poisson. Alright, Poisson of R. Make it large. It's just like. Alright, this clearly. Is this one, right? This is Poisson. Poisson, we know the mean of x is alpha. Variance of x is also alpha. Okay, then we can use these two. Here, we know Ex is alpha, and the variance is also alpha. Okay, these alpha are just alpha here. They are not the significant level. They are not the confidence level. Now we use beta for the confidence level. It is 90%. Alright. Then we have these two. Okay, then we can add these, plug these here. Then we have more details about z of n. Okay, I just leave it here. Now find C so that the probability Zn smaller than C, this probability were larger than the given significant level is 90%, which is 0.9. You want to find the C. Now how to find this C? Because Zn is a normal distribution, right? So we have this is a PDF of Zn. We can have these. And we want the interval, the absolute value. Here's a 0. Here's a 0. Right? This is if this is Z, here's a Z equal to 0. The Z absolute value smaller than C will be a interval from negative C to C. And we want this part is 90%. So you can separate, right? This part should be what? How many be here? How many probability will be here? This should be 5%, right? And this side will be another 5%. The total is 100%. Right? The middle is 90%, and both sides each you have 5%. Okay, then what is the C? C is here. We have phi of C were equal to 0.95. Make sense? Because this part is 5%, right? This part is 5%. Then phi C will be all the rest part. So you need 1 minus this 5%. I have 95%. So this is phi C. Okay, we can get C. C equal to what? We check the table. I put the table here. Alright. So we want to find the phi C equal to 0.95 here. So you see, you need to check the value of phi and find where this 90.95 should be here, right? 95. Okay, it's here. We have 0.9505 or 0.9495. So both, they have the same arrow. One is larger, one is smaller than 95, with arrow is 0.0005. So you can choose either one. Or if you want, you can use a middle value between them, the average value between them, right? Like here's a Z will be 1.64 or 1.65. You can also use a value between them, the middle value between them. That will be 1.645, right? Yeah, okay, just use that. Let me write it. C will equal to 1.645. Okay, we have C. We have C. You get it just from the table. The meaning is here. The meaning is here. Okay, so you have this C. So probability of Zn smaller than C is larger than, actually is equal to 0.9, equal to 90%, right? This part is equal to Yeah, we want it larger than or equal to is fine. Equal to, we have this. Now try to rewrite. Try to write this part. The n smaller than c in term of like this is probability sum. No, this is interval. Write this in terms of like set smaller than sum b, larger than sum a, things like this. Things like this. Now set is alpha. We want to estimate alpha, right? For this example, we want to estimate this alpha. Okay, x of a Poisson distribution with parameter alpha. Then we want to estimate this alpha. Okay. Then we can plug in, because we have these two numbers. We have Ex is alpha, variance x is also alpha. So we can plug Ex is alpha here, and the variance of x is also alpha here. Right? Okay. And this one, we know this, right? We know this. The mean of this 100 sample is 14.6. Yeah, mean is this one. So 100, right? At times 100, that will be the summation, right? Okay. So C is, I guess C this one, right? C is this one. And this one is smaller, the n smaller than C is just the summation of xi minus n times ex over square root of n variance of x absolute value smaller than C. And then we plug in the given values. This is 100 times m100x minus n alpha over square root of n alpha. Absolute value smaller than C. C is 1.645. Right, we just get it from the table. I just get this from the table. This is this one, and ex now is alpha. Ex is alpha. Variance of x is also alpha. Or n is 100. N is 100. N is 100. And this one is 14.6. Okay, 14.6. Okay. Then let me write this is times 100. This is 1460 minus 100 r over square root of 100 is 10. 10 times square root of r smaller than 1.645. Okay. Then let me times this in that side. I get 1460 minus. Let me see it's correct, right? Yeah, variance is also alpha. Variance is alpha. So this one minus 100 alpha absolute value smaller than, I times this to that side, 10 times it at 16.45 square root of alpha. Then we have this. Okay, if I remove this, then I get two things. One is 1460 minus 100 alpha or smaller than 16.45 square root of alpha. The other side is 1460 minus 100 alpha or larger than negative value of this. Right, I have these two. Right, absolute value is smaller than this. So you remove absolute value, you have these two. Things like this, right? Yeah, absolute value. Absolute value is smaller than something. Smaller than something. Then can we solve what is the alpha? Oh, but it is second order. Okay, alpha is second order. This one is a little bit complex. Let me see. It will be, I move 100 to that side. I have 100 alpha plus 16.45 square root of alpha minus 1460 should be positive, and 100R minus 16.45 square root of R, and minus 1460. This one were less than 0. We have these, right? We have these. Then I suppose I denote the square root of R as a P. Yeah, for convenience, the P. Then I have 100 P squared. Okay, I remove 100. I have P alpha is P squared and plus 0.1645 P and minus 14.60 larger than 0. And this is P squared minus 0.1645 P minus 14.60 smaller than 0. I want to estimate that I need to find the poles. Okay, so find poles, I use MATLAB. Alright. Yeah, you can also try to use just handwriting too on paper, solve it on papers, but we can have more faster tools, right? Okay, MATLAB, we can use MATLAB can have function find the roots of polynomials. Roots of polynomials. We write the polynomial. Okay, just they have function roots. Roots of. We put the coefficient of the polynomial here. The first one is P squared has coefficient 1. The P has coefficient 0.1645, and that constant is negative 14.60. Okay, alright, then we have this one. So the first part I can write as P plus 3.9041 times P minus 3.7396 larger than 0. You got it? When you have two poles of a polynomial, you can write the polynomial in this way. So negative 3.9 is a pole, is a 0, is a root, and the positive 3.73 is another root, right? Okay, this is the first one. And the second root, I want the coefficient here is a negative, and not here. Here's a negative, and then that is also negative. Okay, this one. Alright, we have another set of roots. So I have P now is minus 3.9041 times P plus 3.7396 larger than 0, smaller than 0. This second is smaller than 0. Okay, then how to solve it? You can see this is a multiplication of two factors. You want it positive, you need both are positive or both are negative. And this one, you times them together, you have a negative value, smaller than 0. So these two numbers, one should be positive, one should be negative. So totally, I have two equations. Each equation I have two cases. So totally I have 4 cases. We have cases 1, I have both are positive, and the second one has a positive and negative. This is the case, right? And actually I can put cases that both are positive. This is first is negative, second is positive, right? This one and this one, and both are negative. These are both factor are negative, and these two, first is positive or second is positive, right? So totally we have these four cases. We will discuss which cases can give us the right answer. Alright, so we check this one firstly. This one give us P plus 3.9041 positive, P minus 3.7394 positive, and the P minus 3.9041 positive, and the P plus 3.7396 is negative. I have these four. So this one gives us P were larger than negative 3.9041, right? And this one gives us P were larger than positive 3.9394. And this one gives us P were larger than positive 3.9041. And finally, P were smaller than negative 3.7396, right? Okay, this is impossible, right? You see, P should be larger than the positive value as well as smaller than the negative value. Impossible. Okay, so for this case, no solution. Alright, we check case 2. This is case 1. I use this as case 2, case 3, case 4. For case 2, I still have P plus 3.9041 positive, P minus 3.7394 positive, but this one is negative. P minus 3.9041 is negative, while P plus 3.7396 is positive. So we have these four. These four give us P were larger than negative 3.9041. Second is P larger than positive 3.7394. And the third equation gives us P smaller than 3.9041. And the last is P larger than negative 3.9396. Okay, this case we have solution. You see, we have negative value, negative 3.9. Oh, I have two, the 3.93 and the 3.90. I have two, these two are 3. Okay, it's the same thing. Oh, this is 7. I'm sorry, 7. It's 7. Put the wrong one. Okay, we have four values: the negative and the positive 3.9, negative 3.9, and the positive negative 3.7 and negative 3.7. The first equation, this is a P. P were larger than negative 3.9. This is this one. Okay. Second equation, larger than 3.7. The third one is smaller than 3.9. For the last one is larger than negative 3.7. Okay, we have the common area is here. The common interval is here. Alright, so we say P will be a number 3.7 smaller than P smaller than 3.9. Okay, this gives us a value. We say alpha was smaller than 3.9 square and larger than 3.7 square. So what that is, let me put the value 3. I just use this one with square. That will be fine, right? Okay, 3.9. Actually this is 3.9041 square, so this should be 15.24022, and this is 3.7 square, that will be 13.9848. Okay, we have an interval estimation of alpha. But this is just one of it. Maybe we have another. So we also need to check case 3 and 4. Case 3. Case 3. Case 3 is a negative, negative, and a positive, negative. So these two, I need a negative. So P plus 3.9041 should be negative, and the P minus 3.7396 also negative, and positive and negative. So this is positive. P minus 3.9041 is positive, and the P plus 3.7396, this will be negative. 6. Okay, we have this 4, and this 4 is this work. I still use these three numbers. I need a negative 3.9, negative 3.7, positive 3.7, positive 3.9. The first one was smaller than these, right? Smaller than negative 3.7. Oh, this one is impossible, because we also have this one. This one, P were larger than these, right? P were larger than this, and these two, they cannot happen at the same time. So no solution. And case 4, we still have these smaller, these negative, right? Smaller than 0, negative, and we want this is negative, but this one is a positive. 7396, this is a positive. We have these. Then I still have these 4 values. Right? The first one we want smaller than these, and this one smaller than these, right? The second equation. Third equation we want smaller than these. Okay, these three we have common areas here, but the last one we want P larger than these, right? Larger than negative 3.7. Okay, no solution. Right? Smaller than these, but larger than these, impossible. So no solution. Right? These two, they cannot happen at the same time. No solution. No solution. Alright. Okay. So far we discussed all the cases, and we say this is the only choice. This is the only choice. So we have the interval estimation. It's a 13.9A4A, smaller than R, smaller than. If you want to put equal, is also fine. This is a kind of continuously. We do not care just one point, right? So put equal and no equal, it doesn't matter. So we have the interval estimations like this, All right, yeah. For this one, actually, the mean is alpha, right? Mean is alpha. So if we use a point estimation method, we know the given mean, which is where it is here, right? This one. For the Poisson distribution, we have Ex is alpha. So we start from this one. We start from some date. If we do some calculator, we know the mean of X from 100 samples is 14.6. Then we can just use this as an estimator of the mean value as alpha. So if we do the point estimation, by point estimation, alpha where we can just use this 14.6 to estimate alpha. And now we use interval way. We have this. We have this. This is the interval estimation, and with confidence level 90%, 95 or 90. I forget. 90%, 90%, right? 90%. Yeah, 90%. All right. This is one case. Okay, this is one case. I said we have some homework problems. Yeah, this is homework problems. We have two cases. If X obey the Poisson distribution, how to estimate alpha. We just finished. And the second one, if X obey exponential, then how to estimate this lambda. We want to find the interval estimation. We do the same thing. We can do the same thing. Okay. Okay. Let me work on that. B. X obey the exponential lambda distribution. Okay, then what is EX? We check the table. We have this, right? We have Poisson. Then let's find the exponential. It's here. Okay. We know EX is 1 over lambda, and the variance is 1 over lambda squared. We have this one. Right? We have this one. So now we still use beta is 90%, right? So we want probability Z smaller, Zn smaller than C. This one were just equal to 90%. So that means phi of C were equal to, we have this, right? Similar with last time. This part is 90%. So here will be 5%. Right? Then phi C will be 1 minus this will be 0.95. Right? 0.95. And then C will be, we just actually same C. Same C. You check the table. I forgot what C. I check the table again. Table, we need 0.95, 0.93, 0.95 Z. 165, 164, 1645. I use the middle one. 1.645. Okay, so this is C. Yeah. Actually, when you calculate this part, you want to find this C, you only need the significant level, the confidence level. You have the confidence level, then you can have this C. Yeah, sorry. Yeah. When you want to determine this C, you only need the confidence level, right? You check the table. You can find the C. Find the C. Then next, okay, now you need Zn smaller than C. You need to write this in an interval way. So this one is Zn is a summation of all those xi, then minus n times the Ex over square root of n times variance of x absolute value. This one is smaller than C. Okay, plug in. This one is 100 of m100 x. Now here we have 100 sample. If you have like 1,000 sample, here it should be 1,000. All right. Then we have this, and this one is 14.6. Right, it's 14.6. So this one is 14.6 times 100. Yeah, still this, right? Still this one. But this is different. So we have 1460 minus n is 100 times Ex. Ex is 1 over lambda. And square root here is n is 100 is 100, and the variance is 1 over lambda squared. Okay, we want this smaller than C. Alright, now we try to rewrite this in terms that lambda were smaller than some C, things like that. Alright, okay, so it is this one. I have 1460 minus 100 over lambda square root, not square root, absolute value over, here square root is 10 times 1 over lambda, right? Okay, this one is smaller than C. So I move this to that side. I have 1460 minus 100 over lambda, absolute value, smaller than 10 C over lambda. C is what? C is this one. C is 1.645. So this is 16.45 over lambda. Okay, I can times lambda, right? Time lambda on both sides. I have 1460 lambda minus 100, absolute value, smaller than 16.45. Okay, let me remove the absolute value. I have 1460 lambda minus 100 were smaller than 16.45 as well as larger than negative 16.45. It's 1460 lambda minus 100. We have these two. Then we can have, okay, 1460 lambda smaller than 100 and 16.45. And this 1460 lambda larger than 100 minus this. 100 minus this, okay, what's that? It's 83.55. Okay. Oh, now we have it. So lambda were smaller than 116.45 over 1460. This will be some number. Let me calculate. It's a 1. Okay, I just leave it here. All right. It's now almost a time, and smaller than this and larger than these, 83.55 over 1460. Okay, so this is the interval. We have the interval estimation of lambda with confidence level 90%. Alright, yeah. Okay, that's all for today. See you next time. Bye bye.